Okay, in this problem set, we're dealing with a lot of issues where typically in a lab or in a clinic, you have a solution that is at a high concentration, and you would never actually use that or apply that solution at that very high concentration, so you have to dilute the concentration. So a lot of these problems will deal with this equation that will help you figure out how much water you need to add to a solution and how much of the stock highly concentrated solution you will need. So this equation I have at the top here is something I'm going to use in a lot of these problems. The symbols here, V and C, stand for the volume of a solution and the concentration of a solution. So the way I'm going to use this is for the left side of this equation, this is going to represent the stock solution or the highly concentrated solution. And the right side is going to be the actual solution you need to apply the volume and the concentration of that solution. So what we're going to do in a lot of these problems is you know the concentration of your stock solution. So we'll typically fill that one in. You'll know how much of the solution you need to apply in the clinic, and you know the concentration that is relevant for that application, but you will need to figure out what volume of the stock solution you need. So this is the basic setup of how we're going to fill in the variables and solve for V1 in this case. Okay, so in this first problem, it says the veterinarian needs 100 milliliters of 10% formalin, and you are going to take this and probably collect a tissue sample and fix it to preserve it for a pathologist to look at and see if there's an issue with the tissue that can be diagnosed by looking at that preserved sample. And you have a stock solution that is identified as 100% formalin. So we're going to use that for our C1. So V1 is still not going to be known. We're going to use that 100% as our concentration. And you don't need to actually change that to a decimal, as long as you have percentage on the other side of the equation. So what we actually need for clinical application is the volume of 100 milliliters. And we're going to multiply that times the proper concentration, which is 10%. Okay, so if we do some quick algebra on both sides, that's going to simplify the equation down to 100 times V1 equals 100 times 10 is 1,000. Divide out both sides of that equation by 100, and you get V1, which is how much of your stock solution you need, comes out to be 10 milliliters. Okay, notice that in the question they want not only how much formalin, which we've already answered here, but they also want how much water, because you're taking this concentrated 100% solution and diluting it down to 10%. So since you've got 10 you need to start with from the stock solution, and you need to get up to 100 milliliters to completely answer this question, you would want to say you need 10 milliliters of formalin, and you are going to combine this with 90 milliliters of water. And when you add those two together, these two are going to give you the 100 milliliters that was originally cued in the question. Okay, so in the second question, we're going to do something very similar. So we'll start off with that same equation. And in this case, your application is going to be 50 mils of a 5% dextrose solution. Dextrose is a carbohydrate solution, and that makes sense because you're trying to give this to a hypoglycemic dog who has low blood sugar. And your stock solution is 50% dextrose. You're going to need that information too. And this is somewhat extraneous or extra information, but the problem says that you need or you have 250 milliliters of sterile water. Now, it doesn't mean you have to use that, it just means when you dilute this concentrated solution here, you're going to need some sterile water because you're probably going to deliver this by an IV, but you don't necessarily need all of that. You'll probably only use a portion of it to dilute your dextrose down to 5%. Okay, so if we fill in our equation in the same way, again, we're always starting off with the stock solution on the left, so you don't know how much of it you need, you don't know your volume, you know that the concentration is 50%. On the right side, you need a volume of 50 milliliters, and your solution to apply will be 5%. Okay, so again, just going to do some quick algebra here. 50 times V1 on the left side, 50 times 5 on the right side will give you 250. Divide each side by 50. And you find that you need just 5 milliliters of that stock solution, or 5 milliliters of the 50% dextrose. Okay, now just like the first problem, you need to actually explicitly say how you're going to dilute this out. So we already did the first part, the milliliters of dextrose you need, and add water to get your final volume. So we're going to do 5 mils of the dextrose plus 45 mils of water. Those would be your two answers for the question. And again, you're doing 45 milliliters with the 5 milliliters of stock solution because that is going to give you your 50 milliliters total. Okay, and problem number 3, this says the vet needs 1,000 milliliters of a rehydration solution with 2.5% dextrose, and you have 50% dextrose, but instead of just using water, it looks like we're going to use this rehydration solution that probably has some salts already dissolved in it. So in this case, what we're going to look at is the setup is the same, where this is what you actually need to apply, and you have a stock solution of 50%. Okay, so starting off with our stock solution on the left, you know that you need 1,000 milliliters, and you know the concentration of that needs to be a 2.5%. So just work out the simple math here on that. Divide each side by 50. And V1, the amount of stock solution you need is 50 milliliters of dextrose. And here we're going to combine that to get up to 1,000 milliliters. You are going to have to combine that with 950 milliliters of the rehydration solution to get your 1,000 total. Okay, another common direction you would get for making a dilution from a stock solution is just this notation separated by a colon, which is a direction to make a 1 to 25 dilution. So for all these problems, we're going to take that notation and write that as a fraction, just 1 over 25. And then on the right side of this, we're going to make another fraction. And if you want to figure out if you have a stock solution, you always put the volume of the stock solution on the top of the right hand of the equation. And then if you dilute that 1 to 25, whatever is on the bottom, I'll just identify as x right now for purposes of solving this equation. That is going to give you the volume of the applied solution. Okay, so what you're really doing is taking the original stock solution and you're adding 24 parts water. So 1 part stock plus 24 parts water is where you get this notation of 1 to 25 dilution. But all you need to set up is a simple equation like this with 2 fractions and figure out your final solution. So here we're going to cross multiply this, take your 1 times x, make that the left side of the equation, and then multiply 25 times 150, which will give you 3,750 milliliters. Okay, so if you take a solution or a stock solution and it tells you to do this dilution, practically what you would have to do is take your 150, do this calculation, and then add water to eventually reach this number. What we did was sufficient to answer the question, which was just figure out how much you can get in the clinically applied solution, the amount you can get of that from your 150 milliliters of stock. Okay, in number 5, I'm just going to use kind of a basic dimensional analysis way of looking at this problem. Here you are going to take solid glucose and weigh it out in terms of grams, most likely. And you are going to make 500 milliliters of a solution that is expressed as 4.5%. And when you're dealing with a solid dissolving into a liquid, typically this percentage is specified as a weight per volume. And for this kind of notation, what that means for translating that into units, I think the best way to look at this is that means 4.5 grams of glucose for every 100 milliliters of solution. So anytime you see percent dissolving a solid solute into your solution, the percentage means the number of grams over milliliters of solution. Okay, so if we take that information that we translated and simply multiply that times the volume of the solution we need, 500 milliliters of solution is what you need there. That will cancel your units out on the top and the bottom of milliliters. It's going to leave you with grams of glucose, which ends up being 22.5 grams of glucose you would need. So after you do that calculation, you would go to the scale, weigh out your glucose, set it aside, and then you would want to mix this with water and slowly bring the solution up to 500 milliliters. So you always want to add your solute first, which would be your glucose, and then bring the water up to the amount you actually need.